Okay, ma'am. So, good morning. In the continuation part of this meiosis 1 process, in the prophase, 5 substages are present. Out of the first one, it is leptotein. So, before that one, in interphase, now the cell is ready for the division. Now, the amount of the chromatin is converted into chromosomes. For example, here I would like to take the number of the chromosomes are 2n is equals to 4. So in the leptotein stage, the nucleus size is enlarged. At last, finally, the homologous paternal chromosomes and maternal chromosomes are attached at a particular point. It seems to be that arrangement of the flowers in bouquet, hence it is called as a bouquet stage. Next, the stage is zygote stage. Here, zygos means yolk or otherwise pair. Zygote. Okay. Next, the meaning of in Greek language, that is tania. Tania means that is nothing but a band, a small band. And the meaning of teen, here leptotein, teen means a thread-like. Tania means band. Zygos means pair. What happened in the zygote stage? I already told. For example, it is homologous paternal chromosomes, homologous maternal chromosomes, both are joined at a particular place. Later on, what happened? Between these homologous chromosomes, attraction forces are developed. Right fingers, left fingers. In between them, attraction forces are takes place. When attraction forces are takes place, one right finger, another left finger is fused. Means it will become pair. So how many pairs are there now? 5 pairs. Individually, how many chromosomes are there? Here 5, here 5. When they are fused, now how many pairs are there? 5. It means during the process of this zygote stage, attraction forces is developed between these homologous paternal chromosome and maternal chromosome. Hence, that pairing process is called as synapsis. So, what is the first point? Pairing of homologous paternal chromosomes with homologous maternal chromosomes. Now they will be formed as a pair. Now the pairing process is called as here synapsis. The pairing process is called as a synapsis. Look at here. Now I would like to say this is the homologous maternal chromosome. Okay. Just beside that one, who will come here? Paternal chromosome. That pairing process is called as synapsis. So now when synapsis is completed, okay, Now here, both maternal chromosome and paternal chromosomes, they are held together by some specialized protein structures. Now, the specialized protein structures which are useful for their pairing process, that protein is called as synaptimal protein or synaptimal complex. It is a protein molecule which are useful for fission of these, means pair of these homologous paternal and maternal. Now the process is called as synapsis, and pair. That pair is called as here, which one means bivalent. Which one? Bivalent. Chromate is already formed, wherein a synthesis during in a replication process. So here the chromatids are not very clearly visible. It is invisible. So what is that diagram here? I would like to sketch. Observe here. This is the zygote. Still, which are present nuclear membrane, nucleolus. Okay. So one red chalk, for example, who is this red chalk? Paternal chromosome. Another one is maternal chromosome. One paternal, another one is maternal. Okay. So when pairing process is completed, what is that pairing process? Homologous paternal and maternal chromosomes both are held together by the presence of some protein structures which are called synaptimal complex, and each pair, this is one pair, this is one pair, each one pair is called as bivalent. That is called as bivalent. Now, here you can observe, here it is also one bivalent. One bivalent. So, come on, tell me, if 2n is equals to 4 is present, what is the number of bivalent? Bivalents are 2, means pairs. Tomorrow in exam, we will ask 2n is equals to 40 chromosomes is present. What is that number of bivalents? How many bivalents? 20. If it is 100, 50. If it is 1000, 500. Pair. Now, so what is the first process in zygote? Pairing of homologous paternal chromosomes and maternal chromosomes. That pairing process is called as synapsis. And the formed each pair is called as bivalent. Each pair is called as bivalent. But we will notice the presence of which one? Two chromatids for each chromosome. So, here every chromosome is having two chromatids. So, here two chromatids. For one bivalent, how many chromatids are present? 4 chromatids are present. For one bivalent, how many chromatids are present? Oh, 4 chromatids are present. Yesterday I was already shown now. This is centromere. This is one chromatid. This is one chromatid. That is, for example, paternal. This is the another one, maternal chromosome, homologous, maternal. This is one chromatid, one chromatid. Now both together called as bivalent. In each bivalent, how many chromatids are present? All these are bits. How many are present? 4 chromatids are present. So if 2n is equals to 4, number of bivalents is one bivalent, another bivalent. In each bivalent, 4 chromatids. Total how many chromatids are present? 8 chromatids are present. Tomorrow they will ask if 2n equals to 40 chromosomes, how many bivalents are present means 20. How many chromatids are present? Each one is having 4. Total how many chromatids are present? 80. For 2n equals to 20 chromosomes. So here the pairing process is different in way. How the pairing process will be takes place. Look at here. The pairing process is 3 modes. One is procentric. The name itself indicates. Procentric means, pro means first, centric means centromere. Now look at here. This is the centromere. Okay, this is that chromatid. This is the another chromosome. Now you think so? This is maternal chromosome. Paternal chromosome will come. Initially, it is attached at which region? Centromere. Further, what happened? Pairing will be takes place. Further, there will be takes place. So, procentric means pairing is happened towards the centromere, center. To away means terminal region. So, center to the process which will be takes place, the last region, that is called as procentric. That is called as procentric. Observe the diagram, don't confuse, almost all it seems to be same, but the starting point pairing you have to be noticed. Another one is proterminal. Okay. Pro means first, terminal means terminal portion. This is the homologous paternal chromosome. Maternal chromosome will come. Maternal chromosome will be attached at first which side? Terminal side. Now the pairing will be takes place towards the center. Now this process is called as proterminal. Okay. So procentric means pairing is happen towards the center and move towards terminal region. Pro-terminal regions of synapsis means initially the synapsis process is happened at terminal region and move towards center. Here center to away, here away to center, center to terminal, terminal to center. It may be happen in this fashion or in this fashion. Sometimes what happened? This is the paternal chromosome. Look at here. Now the maternal chromosome will come. Now the maternal chromosome will come and present like in this fashion. They are not touched towards the centromere. Further they will be attached here. Further they will be attached, pairing. Here and there. At any one point, here this is the maternal chromosome. Paternal chromosome will be attached in the center. So it is maybe takes place at any position n number of times. That is called as random. That is called as random. So what are the key points you have to be remember in a zygote process? In the zygote process, what happened? There is attraction forces is developed between the homologous paternal and maternal chromosomes. Now they are formed as pairs. Now the pairing process is called as synapsis. During the pairing process, these are that attached by the means of synaptimal complex proteins. When they are paired, now when the synapsis is completed, when they are paired, here now the pair is called as bivalent. If you observe that bivalent, okay, listen my words. A bivalent is having two homologous chromosomes. Is it the same or different? They are different. One is which one? Paternal. Another one is maternal. This is bivalent. In each bivalent, how many chromatids are present? 4 chromatids are present. Hence, it is called as tetrad. It is called as tetrad. What bit you have to be remember? Observe the board. 2n is equals to 4 is there. How many bivalents are formed here? 2. How many bivalents are formed here? 2. Every bivalent is having 4 chromatids. Hence it is called as tetrad. Now, how many tetrads are present here? These 4 chromatids is 1 tetrad. These 4 chromatids is 1 tetrad. So what you have to be remember? The number of bivalents is equals to the number of tetrads. How many chromatids are present? Come and tell me how many chromatids are present for each bivalent. For each bivalent, 4. For 2n equals to how many bivalents are there? 2. 2 into 4, 8. This you can take the screenshot. Later on in meiosis numericals we will discuss. This you have to be remember the concept. This synapsis process initially it takes place from centromere to the terminal region. That is called as procentric. It is happen from the terminal region to center. That is called as pro-terminal. It may be it takes place in any places in a different way. Now that is called as which one? Random. So during this process, which are formed means the structures which are useful for the locomotionary purpose of chromosomes. What are the structures are formed for the using of the slightly the spindle fibers formation is also takes place at the zygote stage. Okay, that is the thing. Next, the stage is very important stage. We cannot imagine without this stage for any continuity formation of the life of the organism. For example, what is the stage means? The stage is called as Pachytene. The stage is called as Pachytene. Pachytene means it is derived from a Greek word pacus. Pacus means thick. Pacus means thick. Okay, listen carefully. Every homologous chromosome is having 2 chromatids. They are called as sister chromatids. They are called as sister chromatids. One chromatid of one homologous chromosome, the another chromatid from another homologous chromosome, they are called as non-sistered chromatids. Listen very carefully. This is the final point. Later on we will sketch the diagram. Now this is the homologous maternal chromosome. Now it is having 2 chromatids. These 2 chromatids are nothing but called as sister chromatids. So just beside this maternal chromosome in bivalent another chromosome is present. What is that? Paternal. This is the paternal chromosome. It is also having which one? Their own chromatids. Now, these 2 also called as sister chromatids. So, in each bivalent, it is a bivalent. One is maternal, another one is, for example, paternal. Every chromosome is having 2 chromatids which are concerned for the same type. They are called as sister chromatids. Okay. 2 fingers from right hand, 2 fingers from left hand. Now these two are which one? Oh, sister chromatids. Sister chromatids. First. Okay. Listen carefully. Now they are present like this. How many chromatids are there? 4. 2 are concerned for maternal. One paternal, one maternal. Non-sistered chromatids. Non-sistered chromatids means observe that chromosome. One chromatid from maternal, one chromatid from paternal. These are called as non-sister chromatids. You and your own sister, for example, you are introducing, she is my sister. Now the opposite person will ask, own sister or cousin sister? Own sisters are sister chromatids. And you and your another sister means your uncle's daughter, aunt's daughter, both you are having a relation, sister relation. That is which one? Non-sistered chromatids. Are you clear? Shall I go for the next step? Okay. Now, during the process of which one part-eating stage, all of you look at very carefully. There is the exchange of chromosomal material in between that non-sistered chromatids. There is exchange of chromosomal material in between the non-sistered chromatids. This is, for example, whom paternal chromosome, maternal chromosome. Look at here. I am talking about these non-sister chromatids. Observe that chromosome. On these chromosomes, genes are present. Look at here. This is the homologous paternal chromatid. Now this is the homologous maternal chromatid. So who are exchanged here? One finger of right hand, one finger of left hand. Both are crossed. Both are crossed. So the chromosomal material, chromosomal material exchanged between whom and whom? Homologous chromosomes. But the two, it is happening between non-sistered chromatids. That you have to be remembered. During that process, when the two chromatids which are crossed, now the process is called as crossing over. Crossing over. At that moment, what happened? Listen my words. Some part of that paternal chromosome, is cut, and it is pasted towards which one? Maternal chromosome. Some part of that maternal chromosome is cut and pasted towards the paternal chromosome. I will show with the example. Homologous paternal, homologous maternal. Okay. When this is sister chromatids, these two are sister chromatids. Now these are which one? Non-sistered chromatids. These two are crossed. When they are crossed, a portion of maternal chromosome is cut. A portion of paternal chromosome is cut. Now the paternal chromosome, which the part is cut, it is added towards maternal chromosome. A portion of the maternal chromosome is added towards paternal chromosome, vice versa in opposite. Now that process is called as crossing over process. Now the process is called crossing over. So here one chromatid. These two are not involved. Look at here. They also non-sister chromatids. But here, whichever is very near, that will be exchanged. Observe the diagram. Okay, look at here. This is the chromatid. Okay. Paternal. This is which one? For example, maternal. A portion of maternal chromosome, it is cut. Okay. Now it is pasted towards maternal. A portion of that one, it will be cut and it is having that opposite one. Now this is the chromosome. Observe the maternal chromosome. Whenever it is crossed, what happened? See the red mark, paternal. Whenever they are crossed, it is having which one? Maternal. See this one, blue chart. It is having. Now this is the diagram. Okay, so I will show you with another example also. Okay, sister chromatids. Okay. Another one is non-sistered chromatids. Look at here. Okay, which I am showing. This is the non-sistered chromatid from each strand. Okay, during this process, these are exchanged. These are exchanged. When they are exchanged, look at here. I am going to draw this one. This is a portion of which one? Paternal chromosome. This is a portion of maternal chromosome. Towards these paternal chromosome, who is added? Maternal chromosome. Towards that maternal chromosome, who is added? Now, are you all got that difference? Are you understand? Now, this is the exchange of chromosomal material in between the non-sistered chromatids. Now, the process is called as crossing over process. And they form a nodule-like structures. These are called as recombination nodules. These are called as recombination nodules. So here, what you have to be remember? You should be remember two enzymes here. Listen carefully. I would like to sketch that diagram finally in this fashion. So this is paternal chromosome. Okay. This is maternal chromosome. Listen carefully. Observe the diagram. A portion of maternal chromosome is cut. A portion of paternal chromosome is cut. This is the cut portion of this one. This is the cut portion of paternal. Now, the chromosomal part, it will be cut with help of a enzyme, a small nicking, crunch. Now, that portions will be cut. Now, the process here, it is called as nicking process. Here, you remember, one enzyme is responsible for to cut that DNA part or chromosomal part. Now, the enzyme name is called as restriction endonuclease enzyme is cut. Restriction endonuclease enzyme is cut the portions of whom? The portions of whom? Look at here. Exchange. During this exchange, what happened? It should be cut. Now you think so. My fingers are scissors. This is the enzyme. Restriction, endonuclease enzyme. It nick the paternal chromosome and maternal chromosome. Cut. After that, this cut portion of the paternal, it will be united with the paternal. Paternal part is united with the maternal. Opposite. So during this process, another enzyme is present. It is useful for the union of chromosomal parts. So for your understand, chromosomal cut parts. Look at here. During this process, what happened? Okay, now it will be carried out by restriction endonuclease enzyme. Further, it is united to whom? Paternal chromosome. It is going to be joined by an enzyme. What is that enzyme? DNA ligase is the enzyme. DNA ligase is the enzyme. So, now the portion of this paternal chromosome, it is attached to whom? The maternal one. It is attached to the maternal. This is the process. So, in Pakitian stage, what we have to be observed, there is exchange of chromosomal material in between that non-sistered chromatids. During that process, when the cross is over, that is called as crossing over. In the crossing over process, a portion of the maternal chromosome is cut and pasted towards the paternal. A portion of the paternal chromosome is cut and pasted towards the maternal. Now, that the process, one will be nicking, crunch or cut by the restriction endonuclease enzymes. The another one enzyme which is responsible for the union of that fragments, now that is called as DNA ligase enzyme. Are you clear? This is the root cause to produce different genetic recombinations. Genetic recombinations. It is useful to root cause for the origin of species. Origin of species. Look at here. Why you and your brother is not exactly same? Yesterday I told a small story. Why you and your sister are not the same in height or etc. etc. Now I would like to sketch. Look at here. This is mother chromosome M. Here genes are present. For example, 3 genes are present. Look at here. One gene X, another one Y, another one Z. What is the X characteristic of gene? X character of that gene means it is responsible for the height of the organism. Your mother height, for example, short. Next, Y chromosome means Y gene. It is responsible to give rise to skin tone, color, skin tone, white. Okay. Z, it is gives rise to curling hairs. Curling hairs. So, this is which one? Mother chromosomal gene characteristics. Okay. Next, we will take that father chromosome. Okay. We will take that father chromosome, paternal one. In the non-sistered chromatids, here the genes are A, the genes are B, the genes are C. What is the characteristic of A gene? A, father is 6 feet high. Okay. Pleasing characteristic. Father is black. Okay. C gene. It is responsible for normal hair. Normal hair. During the sexual reproduction process, there is exchange of chromosomal material. Exchange of chromosomal material in between whom and whom? Non-sistered chromatids. For example, now A portion is cut. A portion is cut. That portion is cut. This jet portion is attached towards whom? Father chromosome. A is attached to whom? Mother chromosome. A new baby is formed. For example, now the new baby is male. New baby is the male. If you observe this baby, tomorrow, day after tomorrow, as the span is going to be increased. Now, the person, he will become almost all 5.5 feet height. Now, in that boy, X is the boy. In the X boy height, height is the characteristic derived from whom? Father. Okay, listen carefully. Height is good here, accepted. But this person is having curling hairs. Who's that curling hairs characteristic? For example, mother. Means here also, which gene is transferred here? Z gene is transferred. Now this is the first baby. First baby. First time pregnancy. A new infant is born. There is no rule. Always the same kind of the genes should be transferred into their progeny. Next time, when second time conception is takes place, under such condition, now you think so. Here, which are the genes are present? X, Y, Z, and as well as A, B, C. Now, during in the intercourse, for example, here X is gene is transferred. Here, which gene is transferred? Okay, C gene is transferred. A new baby is formed. Once again, you think so. The same. Once again, you think so. Once again, the second time is also boy. Now, the second boy, if you observe. What happened in this second boy? Whose character? X character is shifted from the mother chromosome. That's why he is only 5 feet high. Okay. Now the C gene is transferred. Is having a normal hairstyle. Both these two sons are derived from the same mother and father. Now the sexual reproduction is there is exchange of chromosomal material in between the non-sistered chromatids. That chromosomes which is exchanged, every time they are not having the same kind of genes. They are different. That's why we seems to be not alike one. You and your brother is not exactly same. You and your sister not exactly same. Your brother and sister is not exactly same in external appearance. Father boy is black. Now the daughter is white. One is having curling hairs. Another one is not having curling hairs. So from parents to progeny, same characters will be transmitted along with unsimilar characters is also transmitted. This is the root cause. to form which one? More genetic recombinations. More genetic recombinations. So this is the major process. So what diagram we have to be remember here? In the Pakitian stage, according to this diagram, 2n is equals to whom? 4. There is exchange of chromosomal material between these non-sistered chromatids. Between these non-sistered chromatids. Still, nuclear membrane, nucleolus is present. So, this is about Pakitian stage. What happened in Pakitian stage? Crossing over is happened. Exchange of chromosomal between non-sistered chromatids. After that, what happened? Two enzymes are involved. One is restriction endonucleases enzymes. They are useful to cut the portions. Later, another enzyme is involved. What is that enzyme? To join the fragments. That is called as DNA ligase. So this is called as Pakitian stage. So for your understanding, a small story. In the beginning of that film, hero and heroine. Okay, at first they never share a cup of coffee side by side. A bench is there, opposite to two chairs is there. Okay, maternal chromosome, paternal chromosome. After that, directly they never marry. They are used to exchange their looks. They have to inform their parents. It may be either arranged marriage or love marriage, whatever it may be. In between that, male and female attraction forces are developed. So during that process, pairing will be takes place. Now the pairing. So this is the which one before engagement. After engagement, you are present here, heroine is present there. No, both are side by side. That pairing process is called as synapsis. After that, sexual reproduction. During the sexual reproduction, there is exchange of chromosomal material in their sperm as well as ovum. During that formations, what happened here? Pakitian stage. Now marriage is over. Tomorrow we will discuss what about their children. They will apply for divorce here. We will discuss the remaining story. Are you clear? You remember a small that kind of story. So what happened up to this mark? Now after interphase, whereas in leptotin stage, all homologous paternal chromosomes, maternal chromosomes at one point. Later on, the pairing process will be takes place. That is called as synapsis. In Pakitian stage, there is exchange of chromosomal material in between the non-sister chromatids. They are formed recombinant units. Now the process which is completed is called as crossing over. It is responsible for the more genetic recombinations and root cause for the origin of species. Origin of species. Now you can take that brinjal variety. Brinjal varieties are different type. Normally our familiar brinjal. Now you think so. This is our normal familiar brinjal. One is green in color, another violet in color. Now another brinjal varieties, different. Origin of different kinds of species. Everything is goes to the credit of Pakitian stage. Tomorrow we will discuss the remaining two stages. One is diplotin, another one is diakinesis. Before to start to explain these two, we recall once again this one. Then we will complete prophase